Hello everyone, welcome back to our GRE series. I'm Eli Andy, a GRE trainer here at the International Scholars Program. Today we'll be looking at probability questions that touch on dice, that is rolls of die or dice. These questions are relatively common in the GRE, so we'll be tackling a few problems to see how ETS sets these questions and also the strategies we can use to solve them. So welcome and let's begin. We'll start with this one. A gambler rolls 3 fair six-sided dice. What is the probability that 2 of the dice show the same number, but the third shows a different number? So we have 3 dice, and we want 2 of them to have the same number, but the third to show a different number. So the first task here is to look at the arrangements or the possibilities. That is the ways, the number of ways or the different scenarios that can give us 2 dice having the same number, but the third one having a different number. For example, let's say the first die reads 5. If we want 2 of them to have the same number, it means another one should also have 5, but the third one should be different. For example, it should be 4. But is this the only way we can have 2 dice showing 5 and a third one showing 4? It's not, because for example, we can also have 5, 4, 5, and 4, 5, 5. So for all of these, 2 dice have the same number, but the third one have a different number. So we can say if we are to use S for the dice showing the same number and D for the die having a different number, we can have S, S, D, and then, or we can have S, D, S, or we can have D, S, S. So that is the first step, understanding what the question is asking for so that we know the possibilities. Now, after this, let's look at how we can calculate the probability of getting S, S, D. Here, the thing to keep in mind is that for the first die, we are not interested in a specific number. It can be any number. And because a die has 6 numbers, our die has all this. It means for the first die, the probability of getting any number will be 6 out of 6. Because for the first die, we are not interested in a specific number. But then for the second die, we are interested in the number that is similar to the one for the first die. For example, if we got a 5 in the first die, then for the second die, we also want a 5. So this one is specific. It is only one number out of all the 6 that we want. What about for the third die? Can you figure out what it should be? Okay, for the third die, it should be different from all the others. So for example, if we had a 5 here, the third die can be any of the remaining numbers. So that will be 5 out of 6. Now, probability rules dictates that for and, we need to multiply. So for SSD, we'll have 1 times 1 over 6 times 5 over 6. That will give us 5 out of 36. So take a look at the remaining possibilities. That is SDS and DSS. What do you think they should be? If your answer is 5 out of 36 for each, then you are right. So our question can be this or this or this. So that means 5 out of 36 or 5 out of 36 for the second arrangement or 5 out of 36 for the third arrangement. Now again, probability rules dictates that for OR, we should be adding. So we should be having here 5 out of 36 plus 5 out of 36 plus 5 out of 36. That gives us 15 out of 36. Now we can reduce this to its lowest form by dividing each term by 3 to get 5 and 12. So our answer is 5 out of 12. That is B. Let's look at another example. A fair six-sided die is rolled 3 times. What is the probability that the result of exactly one of the rolls will be an even number? Okay. This one is not that different from the first example, but what we need to know here is that we want to have even for one die, but then odd for the other two. So the arrangements we can have are for the first roll even, second odd, third odd, or odd, even, odd, or odd, odd, even. So let's calculate the probability of getting this first arrangement. So the probability of getting an even number would be the number of even numbers in that die over the total, which is 6. So for 1, 2, 3, 4, 5, and 6, the even numbers are 2, 4, and 6, so 3, giving us a half. The probability of getting an odd would be the number of odd numbers, that is 1, 3, and 5, that is 3 out of all the numbers. So that is also a half. So for our first case here, we can have a half and a half and a half. And we said in the previous question, if we have and, it means multiplication. And that would give us 1 out of 8. So what the question is asking for, the probability that exactly one of the rolls will be an even number, it can be 1 over 8 for this first case, or 1 over 8 for this second case, or 1 over 8 for the third case. Again, probability rules dictate that for or we add. So that's 1 over 8 plus 1 over 8 plus 1 over 8, which gives us 3 out of 8. So that's in terms of fraction. But the answer choices are decimals, so we need to convert this. 3 over 8 will be 0.375. So that is the probability that if you roll a six-sided die 3 times, only one will be an even number.
You are watching Success with Bob Mwiti Show, presented to you by the International Scholars Program. The International Scholars Program is an award-winning international education financing scheme that helps bright students to pursue graduate studies abroad regardless of their financial background. You can find our programs by going to www.internationalscholarsprogram.com. The International Scholars Program, empowering dreams.
Let's look at this third example. This one is a quantitative comparison question. A six-sided die is rolled several times and the results recorded. So for quantity A, we need to calculate the probability of rolling a prime number on each of the two rolls. So we have the numbers 1, 2, 3, 4, 5, and 6. The prime numbers here are 2, 3, and 5. So we have 3 prime numbers. So the probability of getting a prime in one roll would be 3 out of 6, which is a half. The probability of getting a prime and then a prime would be a half and a half, which is a half times a half, which gives a quarter. So our quantity A is a quarter. Okay. Quantity B reads the probability of rolling an even number or a 1 on each of the 3 rolls. So again, probability of even or probability of even or 1. That is what we want. So for one roll, probability of even will be, how many even numbers do we have? 1, 2, 3. So 3 out of 6. Or 1. Probability of getting a 1 is, we only have 1 out of the 6 numbers. So that would be 1 out of 6. And we said or what do? We add. So this one will be 3 over 6 is a half plus 1 over 6. That will be 3 plus 1. So that will give us 4 over 6, which is 2 over 3. So that is the probability of getting an even number or a 1 in one roll. But the quantity B is 3 rolls, not 1 roll. So again, we need to know the rules of probabilities. For consecutive probabilities, you raise the probability to the power of those consecutive numbers. What I mean is, if you do something n times, and you want to know the probability of a certain event done n times, then you just have to calculate the probability once and raise it to power n. So in this case, the probability of getting an even number or a 1 when rolling the die once is 2 over 3. But when you roll the die thrice, the probability of getting the same thing in all those rolls will be 2 over 3 to power 3, which is 8 over 27. So that is our quantity B. So your task here is as simple as comparing a quarter and 8 over 27. And you can see that 8 over 27 is bigger than a quarter. So our answer is quantity B is greater. Let's go to our fourth example. John rolls a fair 6-sided die with the faces numbered 1 through 6 twice. So in this case, the die is rolled twice. This one is also a quantitative comparison question. The probability that both roles are even, that is quantity A. Both are even. So let's see what we have for quantity A. So the first one is even, the second is even. So that would be P even and P even, where P is the probability. So we have 1, 2, 3, 4, 5, and 6. The even numbers here are 3. Over the total, that is 6, and that is a half. So an even number and an even number, that would be 1 over 2 times 1 over 2, giving us a quarter. You can also view it as that 1 over 2, but now this is done twice, so you raised it to power 2, still a quarter. So our quantity A is a quarter. Now, the second one, that is quantity B, is the probability that both roles are not odd. Look at this quantity B keenly. How would you translate it? What does it mean? Take a moment to think about it. Now, reading probability that both are not odd means that we can have even, odd, even, or even, odd. Basically, you can't have both roles giving you odd numbers. Now, let's see. Do we really have to go through each of these cases one by one to calculate the probability that both roles are not odd? Not really, because there's a rule in probability, the complement rules, that we can use to calculate this quantity B very fast. That is, the probability of something. So maybe if you were to use an example, the probability of getting odd plus the probability of getting not odd sum up to 1. The probability of something plus the probability of not that thing add up to 1. So if you want to get the probability of not odd, all we have to do is to get the probability of odd and then subtract it from 1. So in our case here, we just need to get the probability of odd and we subtract it from 1, and that will give us the probability that both roles are not odd. And this makes sense because calculating the probability of odd is much simpler than going through all this arrangement. So the probability of not odd twice is probability of odd. That will be how many odd numbers? 1, 2, 3. So that is 3 out of 6, which is a half. But it is rolled twice. So that is to power 2. So that gives us a quarter. But our question requires probability that both are not odd. So that would be P not odd would be 1 minus the probability of getting odd that we have calculated here as a quarter. So the probability that both are not odd would be 3/4. So our quantity B is 3/4. So you can see how the complement rule really simplifies things down. So in this case, our answer is quantity B is greater. That brings us to the end of our GRE session today. Hope you learned something on how to solve probability questions dealing with the dice. Bye and welcome back next time.